All right, this is 7-2, number 14. So with this one, we just have a lot of pieces that we need to put together. So the first thing I want to realize here is that there are no exponents outside these parentheses. So essentially these parentheses are saying the same thing as multiplication. I could replace these with multiplication signs and it would mean the exact same thing. So if there's nothing outside the parentheses, it's the same thing as multiplication. So that is assuming that there's nothing like no addition happening inside the parentheses. So if there's just multiplication happening inside the parentheses and there's no exponent outside the parentheses, then you're just multiplying everything together. The parentheses mean the same thing as multiplication in this case. So a difference to that would be if I had 2 plus x times 3 plus x, right? This is not the same thing as this. So if there is addition happening inside the multiplication, you have to take care of that first. But here we just have multiplication. So essentially we don't need to worry so much about our parentheses. So bearing that in mind, then we can just multiply all of our numbers together. So if the numbers don't have exponents, right, none of these have exponents, then I can just multiply them together. So I have -3 times 2 times 7. And then I also want to combine my f's together and I want to combine my g's together. So I can't combine anything together that doesn't have the same base. So I'm just going to rewrite this so that I have all of my f's together and then all of my g's together so that I can kind of see what's going on here. Right? So I'm going to multiply all my numbers. So I have -3 times 2 times 7. So that should be -42. So -42 that's my number. So since none of these had exponents, I could just multiply. So that's my number. And then with the f's, I'm going to take all of the x, since these are all being multiplied together, I can take all of the exponents and I can add them. So remembering that there's an invisible 1 right there, right? So I can just add all my exponents. So I have f to the 2 plus 1 plus 3. And then I can do the same thing with my g's, right? There's an invisible 1 here. So I have -3 plus 1 minus 2 because plus -2 is the same thing as -2. So I can just do that. So in other words, this, right, is the same as 1 minus 2 plus -2. So I can think about it either way. So that gives me -42. F to the 2 plus 1 is 3 plus 2 is 6. F to the 6. G to the -3 plus 1 is -2 plus another -2. So -2 minus 2 is -4. -4. So I have -42, f to the 6, g to the -4. Now the last thing I need to do is I need to get rid of any negative exponents. So I do that by moving anything with a negative exponent to the denominator. So remember I have an invisible 1 there. So I can do -42 f to the 6, g to the positive 4. And remember, what matters is that the exponent is negative. This number being negative doesn't mean anything in this case. It just sort of is there. We don't have to do anything with it. We can't change the fact that this is negative. The only things we care about not being negative are the exponents themselves. So if the exponent is negative, then we need to bring that to the denominator and make it positive. So this is my final answer, negative 42, f to the 6, g to the 4th. All right, so you can pause this if you need to write it down. I'm going to erase because now I want to do example number 18. So get ready for that. We're going to do example number 18. This is a scientific notation example. I've done a couple of scientific notation examples in other videos. So if you want more detail on that, there's more in other videos. But here, we're going to do number 18. That does not look like an 8 at all. Okay. This is 6 times 10 to the negative 7th times negative 6 times 10 to the negative 4th. So 6 times 10 to the negative 7th and times 6 times 10 to the negative 4th. So again, we're multiplying everything, so we can multiply the things without exponents together, and we can multiply the things with the same base that do have exponents together. So we can multiply the 6 times the negative 6, and we can multiply the 10 times the 10 to the negative 7th times 10 to the negative 4th by adding the exponents. So I have 6 times negative 6 times 10 to the negative 7 minus 4, which is, again, the same thing as plus negative 4, right? So 6 times negative 6 is negative 36 times 10 to the negative 11. So exponents in scientific notation are allowed to be negative, so we don't need to change that. They are allowed to be negative. But we do want to make this so that it only has something in the ones place. Convention for scientific notation says that we need to have only a number in the ones place. So what we need to do is we need to move the decimal place one place to the left. Moving a decimal place to the left is the same as dividing by 10 to the power of however many times we moved it to the left. So in this case, it would just be divide by 10. But if we're dividing by 10, then we also need to multiply by 10. So when I'm moving a decimal to the left, I need to add 1, right? There's an invisible 1 here. I need to add 1 to my exponent here. So this is going to be negative 3.6 times 10. Negative 11 plus 1 is negative 10. This is negative 3.6 times 10 to the negative 10. Basically, the rules of scientific notation say that this is the format that we need to have it in. So if we're moving to the left, that's like dividing by 10, so we need to multiply over here. So if we're moving to the left, we add to the exponent the same number of decimal places we moved. We add that to the exponent. If we were going to the right, it would be the opposite. It's like multiplying by 10. So if we're going to the right, then we subtract from the exponent, however many places we moved the decimal to the right. And I go into more detail about that in another video. So I'm going to stop that here. Hope this helps with 7.2.